Okay, so let's go ahead and take a look at some word problems. So far the triangles have been kind of set up, and we've been using our knowledge to kind of break things down and set up equations. But now, right, we have words to read and pictures to draw to set up the trig that we're going to be doing. So in the first one, it says that you and a friend are standing 75 feet from a building, and that you note that the angle of elevation from your feet to the top of the building is 55 degrees. How tall is the building? All right, so there's some new language here. This idea of an angle of elevation. So basically, it's talking about being from our feet. So drawing a picture, right? Here's me, right, or you standing there, and we're going to assume that the floor is nice and horizontal. And what they're talking about is the angle, right, of elevation. So looking upwards from this horizontal, they're telling us that that is 55 degrees. All right, and what we're doing is we're looking up, all right, along a building, and so there is basically our right triangle right there. What we also know is that you and a friend are standing, we're 75 feet from the building, so that's basically saying that that edge right there, so the adjacent side of that 55 degree angle, all right, is going to be equal to that. So there's essentially three things, again, we don't know, right? We don't know this, the hypotenuse. We don't know this, which would basically be the side of the building. And we don't know this angle. Let me call it beta. But they're just asking us to find out how tall the building is. So essentially, it's this length. Let me highlight it in red, right? Let's call it h there for height. We don't know what that height is, so let's call it h. So looking at the situation that I have, right, this height is the opposite, and this is the adjacent. So setting this up, it looks like we have the tangent of 55 degrees is that height we're looking for divided by 75, right? Opposite over my adjacent. So we've got it. Multiplying both sides by 75, right? It looks like that height is 75 times the tangent of 55 degrees, right? There is your exact answer. Of course, to find an estimate, we come to our calculator. Let me turn that sucker on. And we're looking at, what was it? 75 times the tangent of 55, and press enter, and 107.1111 feet. And we'll round off to 4 decimals there. Okay, so basically if they're standing 75 feet away, with an angle of elevation from the feet of being 55 degrees, that's saying that the building up to the top is 107.111 feet away. All right. Of course, we can answer other things as well, but they were only asking us to find out how tall the building is. So we're finished. So there we are, basically taking the language, getting a right triangle situation, and then solving that right triangle, in this case, the piece that we need. The next one's a little bit more involved. So let's read it. It says, from the top of a watchtower that is 50 meters high. So why don't we stop there, right? So we have, there's our watchtower. We're told that it's 50 feet high, right? And we're signifying from the top, right? So at the top of a watchtower that's 50 meters high, you see 2 vehicles approaching your position from due east. So that means, you know, let's just kind of say this is the due eastward direction. So I've got 2 vehicles, right? So here's vehicle number 1, right? And here's vehicle number 2. So there's kind of a situation just reading the first sentence, right? So we're at a 50 feet high, and we're at the top, and I see two approaching vehicles directly due east from us. We note that the closest vehicle, so this guy right here, has an angle of depression of 67 degrees. So let's stop there for a moment. Again, an angle of elevation, we're talking about from my horizontal. So there's the horizontal from my viewing. If we were looking up, it would be elevation, but we're looking down, that's depression. So they're basically saying from the first vehicle, right, there's an angle of depression of 67 degrees, okay, and that's from the horizontal. Again, right away, without even looking at anything else, hopefully you guys see the transversal sitting here. If that's 67 degrees, that means that's 67 degrees. So you can see from our vantage point, we have an angle of depression of 67. from this car's vantage point, they actually have an angle of elevation of 67 degrees looking up. So from them, the horizontal, they're looking up. It's an angle of elevation. From our perspective, we're looking down. So from the horizontal, it's an angle of depression. We definitely just have transversals going on. So reading more says that we note that the furthest vehicle, so this guy here, has an angle of depression of 23. So let me kind of draw that in here. Let me orientate myself. So here, right, for that situation, the angle of depression is 23 degrees. And again, because of the transversals going on, from their perspective here, they're looking up at an angle of 23 degrees. And so to make a long story short, right, let me kind of come back to here. We have a situation that looks a little familiar to us, right? We have 67 degrees, we have 23 degrees, this side is 50, all right? Let me kind of come back up here, and let's read. So that's where we're at. And again, their angle of elevation from down here on the ground is matching our angle of depression from up here looking up. What do we know, right? We want to know how far apart, right, the vehicles are from each other. So we basically want to know that distance right here, right? So how far apart are those two people? Okay, and so again, what we're going to have to do is take a look at this in two situations. We have a, let me highlight it here, we have a larger right triangle there, right, and we have a, in red, we have another right triangle situation right there. So we're going to have to kind of piece that together to find out what that x value is, right, with regard to where we're going. And so, again, how about, since this length here is not known, right, why don't we just go ahead and just call this, for lack of a better phrase, why don't we just call that y for the moment, all right? And so looking at this initial right triangle, right, we have 67 degrees, we have 50, and we have y. And so as far as the 67 degrees is, this is opposite, and this is adjacent. And so basically we have as the tangent of 67 degrees is my opposite, 50, over my adjacent, which is y. And if we start solving for this, multiply both sides by y, we get that y tangent of 67 degrees is equal to 50. If we divide both sides by tangent, we now know what that y distance is, right? So y is basically 50, and how about I write it like this, just so we can get rid of the fractions, right? 1 over tangent is cotangent, all right? So we have 50 times the cotangent of 67. So we know that this has that length, all right? So what about the bigger one? I might have to go to another page here. So for this bigger one, we know that's a 23 degree angle. We've just found out that this length is 20 cotangent of 67 degrees, excuse me. We're trying to find this distance here, x, and we know that that's 50. So putting this together, right, let me go ahead and come to another sheet of paper, right, here's what we've got. All right, so for this, right, for that 23 degree angle, this is opposite, and these two together right here are adjacent. So again, I have another tangent. So it looks like we have, let me bring this up a little nicer. So the tangent of 23 degrees is equal to the opposite, which is 50, over the adjacent, which is x plus 50 cotangent of 67 degrees. All right, and so now what we can do is we have an equation to solve for that x. And so I think I would first begin by clearing the denominator. So how about we multiply both sides by x, 50 cotangent of 67 degrees, and whatever we do to one side, we multiply the other. So x plus 50 cotangent of 67 degrees. All right, and so that gives us x plus 50 cotangent of 67 times tangent of 23 equals to 50. All right, distributing, we get x, the tangent of 23 degrees, right, plus 50, the cotangent of 67, times the tangent of 23 degrees, right, is equal to 50. Solving for x, my next move would be to subtract all this stuff. Alright, so doing that, we get x tangent of 23 degrees is equal to 50 minus 50 cotangent of 67 degrees tangent of 23 degrees. And we're almost done, right? So to get x by itself, I'll divide both sides by the tangent of 23. And what I basically have there, right, is x equals 50 minus 50 cotangent of 67 tangent of 23, right, all divided by the tangent of 23. So there is your exact value to this, all right? Of course, we're going to have to strategize how we want to put that into our graphing calculator, right, given that we have some cotangents and stuff of that nature. So how about, we're already almost 12 minutes into this. This is getting a little lengthy. I'll show you the calculator work in another video, all right? Sorry about that. That got a little out of hand on me.